if A, B, C are in HP, show that A is to A minus B is equal to A plus C is to A minus C. So for solving this problem, I will show you one more definition of harmonic progression. Three numbers A, B, C, suppose we have three numbers A, B and C, they are said to be in harmonic progression if A is to C is equal to A minus B by B minus C. And to show why this is so, we already know that if these three numbers are in harmonic progression, we know that 1 by A, 1 by B and 1 by C are in arithmetic progression. So how is this definition equivalent to this? All you have to do is just cross multiply this, so you will get AB minus AC is equal to AC minus BC, and this becomes AB plus BC is equal to 2 times AC, and if you divide this entire equation by ABC, you get, that is, I divide this by ABC, divide by ABC and divide by ABC, so you get 1 by C plus 1 by A is equal to 2 by B. So it means that 1 by A, 1 by B and 1 by C are in arithmetic progression. So these two definitions are equivalent, right? So we know from here, to solve this problem, we know that A is to C is equal to A minus B is to B minus C. So we know that this is true because A, B, C are in harmonic progression. So this implies that A is to A minus B should be equal to C is to B minus C. All I have done is just bring A minus B to the denominator on the left hand side and bring C to the numerator on the right hand side, right? Now if you remember, in the ratios chapter we discussed that if M is to N is equal to P is to Q, right? If M is to N is equal to P is to Q, then each of these ratios is equal to M plus P by N plus Q. So just simply apply this over here. You add the numerators, you get A by A minus B is equal to C by B minus C should also be equal to sum of the numerators, which is A plus C, and sum of the denominators, which is A minus C. So with this we have proven that A is to A minus B, which is this term over here, should be equal to A plus C is to A minus C, which is this term over here, and we are done. Let us look at problem number 7. If the nth term of a HP be equal to n and the nth term be equal to m, prove that m plus nth term is equal to mn divided by m plus n. So let first term of HP be some value a, right? So now, because the reciprocals of HP are in AP, we know that 1 by A plus mth term, so m minus 1 times common difference D. Okay, so this is the common difference that we don't know yet, is equal to 1 by n, right? because the reciprocals are going to be in arithmetic progression, and this is simply a formula for the nth term of an arithmetic progression. Now the other information that is given is 1 by a plus nth term, which is n minus 1 times d, should be equal to 1 by m, because the nth term is equal to m. So now we have two equations. We can solve for both 1 by a and d. So let us try to solve for d first. So if we subtract equation number 1, so if this is equation number 1 and this is equation number 2, what is 1 minus 2, right? So 1 by a cancels 1 by a, and you get m minus 1 times d minus n minus 1 times d should be equal to 1 by n minus 1 by m. This is equal to, if you take the d common out, you have d times m minus 1 minus n plus 1. So this becomes m minus nd should be equal to, if you take the LCM here, it is mn, and in the numerator you have m minus n. So if m and n are not equal, we can cancel. So we get d is equal to 1 by m n. Assumption is that m is not equal to n, right? So we got the d now. What about finding a? So for finding a, we simply substitute the value of d in any of this equation. So you get 1 by a plus m minus 1 divided by d is, so divided by mn should be equal to 1 by n, and this gives us a value of 1 by a is equal to m minus 1 is equal to 1 by n minus m minus 1 by mn, and if you take the LCM, you get m minus m minus 1, right? And therefore this is equal to 1 by mn. So we have the first term also as 1 by mn. So, and what do we have to find? We have to find the m plus nth term. So m plus nth term would be m plus nth term of an AP will be the first term, which is 1 by mn, plus m plus n minus 1 times d, which is 1 by mn, so this means that this is mn 1 plus m plus n minus 1 is equal to m plus n divided by mn. So what, this is the m plus nth term of an AP, right? So what will be the m plus nth term of an HP? Just the reciprocal of this. So m plus nth term of an HP is mn divided by m plus n, and we are done.